So we wrapped up our last video talking about how we can convert one metric unit to another. Centimeters to meters, kilograms to grams, all of that. But we can convert other things too using conversion factors. So a conversion factor is a fraction in which the numerator and the denominator are equal quantities expressed in different units. And conversion factors always equal 1. That does not mean that if you divide one by the other, it becomes 1. It means they're equal to each other. So as an example, 1 inch equals 2.54 centimeters. As a conversion factor, we have to make them into fractions. So we can say that 1 inch and 2.54 centimeters. But to make the fraction, we just put the opposite part on the bottom. So 1 inch over 2.54 centimeters literally means 1 inch equals 2.54 centimeters. Similarly, 2.54 over 1 inch means that 2.54 centimeters equals 1 inch. So we can write conversion factors that relate to some of these pairs. So liters to milliliters. Well, 1 liter might equal 1,000 milliliters, or 1 milliliter could equal 0.00 liters. 1 hour is equal to 60 minutes, and 1 meter could be 0.001 kilometers, or we could say 1 kilometer equals 1,000 meters. All of these are accurate conversion factors. So let's look at how we can use them. So say you were asked, how many minutes are in 2.5 hours? So I start with my 2.5 hours. I don't want to be in hours anymore. So I have to use a process called dimensional analysis. Some people call it the factor label method. I call it dimensional analysis, and I think that's the more common one. We put our units diagonal to each other so that they cancel out. Then you're left in the unit that hasn't canceled. So if I have hours and I don't want to be in hours anymore, I need hours in the bottom. I'm trying to convert to minutes, and I know that 1 hour equals 60 minutes. So I create my conversion factor, which is a fraction, where I put 1 hour on the bottom, so hours cancel, and I put 60 minutes on the top. I enter it in my calculator, round to the appropriate number of sig figs. Now, when we're doing dimensional analysis, only the number in your problem counts towards your significant figures. Conversion factors never count towards your significant figures. So I can have 2, I get 150 minutes. So what's our step-by-step process for this? So you'll read your problem and you'll write down whatever amount the problem gives you. Don't forget your units. Then you're going to think about or look for, depending on what the case may be, what fraction you're going to need to cancel out the unit you started in. And that unit, that's going to be in a fraction. We're going to use the fraction as a conversion factor and determine if the top or the bottom should be the same unit as given, so it will cancel. Put a unit on the opposite side that will be the new unit. If you don't know a conversion between those units directly, use one that will get you a step towards it. You might only need one conversion factor, but sometimes you need more than one conversion factor to make it work. Insert the numbers on the conversion so that the top and bottom amounts are equal, but in different units, once again, like 1 hour and 60 minutes. Multiply and divide the unit. What you're going to hear me say a lot of is multiply the top, multiply the bottom, divide the top by the bottom. That's just essentially my way of making sure you keep order of operations straight. If the units are not the ones you want for your answer, make more conversions until you reach that point. Then you're going to multiply and divide the numbers, and don't forget your order of operations once again. So let's look at an example problem. You're told you have $7.25 in your pocket in quarters. How many quarters do you have? So I start with my $7.25. I know that $1 equals 4 quarters. I want dollars to cancel, so I put dollars in the bottom so that it does, and I put quarters on top. Dollars cancel, I'm left in quarters, and I have 29 quarters in my pocket. I want you to try this one on your own. So if Jacob stands on Spencer's shoulders and they are 2.5 yards high, how many feet is that? Try it on your own, and when you're done, come back. So you should have thought about how 3 feet equals 1 yard. That's a conversion factor I expect you to know because it's English units. And if you set it up correctly, you will have gotten 7.5 feet tall. Let's do a learning check. So you're told a rattlesnake is 2.44 yards long. How long is the snake in meters? Now, that's an example of something I wouldn't expect you to know off the top of your head, and I would give you a conversion factor that you needed. So let's set it up. If I have 2.44 yards, I know I need yards in the bottom so that my units cancel. I put meters in the top. I enter it into my calculator, and I get 2.23 meters. Make sure you're trying these in your calculator yourself so that if you aren't entering them correctly, you can come ask me questions. All right, this one asks you how many seconds are in 1.4 days. Now, I have a feeling most of you off the top of your head don't have memorized the number of seconds in a day. But chances are you know how many hours are in a day, 24. You know how many minutes are in an hour, 60. You know how many seconds are in a minute, 60. So I'm going to start it for you, and then I want you to finish it up. So I start with 1.4 days, and I know that 1 day equals 24 hours. I put days in the bottom so it cancels. I'm now in hours, but I want to be in seconds. So I need more conversion factors to make that happen. I want you to finish the rest of this, and once you do, come back to see if you got the correct answer. For this one, you should have gotten that there was 120,000 seconds in 1.4 days. That's a lot of seconds. Sometimes being able to spot what's wrong helps you be able to do what's right. So what's wrong with this setup? You should very quickly see that I have days here, but I have hours down here. Does that cancel? No, it doesn't, which means this factor is flipped in the wrong direction. I need to turn it the other way in order to be correct. So if you know one conversion factor for each type of measurement, you can convert anything. So if you know that 554 grams equals 1 pound, or that 2.54 centimeters equals an inch, or that 9.46 liters equals 1 quart, we can go from English to metric. Now, I'm not asking you to memorize these, but they will come up a lot in our conversion factors that we do. So let's do a learning check. So we have that an adult human has 4.65 liters of blood. You're asked how many gallons of blood is that? So at first, let's make our plan. I'm in liters, and I want to get to gallons. Now, I know that 1 quart equals 0.946 liters, and I know that 1 gallon equals 4 quarts. This is an example of, I would give you these in the problem to start off with. I wouldn't expect you to have them memorized. So I make my plan based on the conversion factors I'm given. The correct answer is 1.23 gallons. Make sure that that is an answer you were capable of getting by showing your work on your paper. Now, the last thing we need to talk about is temperature. So there are 3 temperature scales: Fahrenheit, Celsius, and Kelvin. Celsius is named after our buddy Anders Celsius, and you guessed it, Kelvin was also named after the guy who found it, except his name was actually William Thomson, but he was made a lord and is Lord Kelvin, hence why he called it the Kelvin scale. Guys naming things after themselves. So how do they compare to each other? So we have Fahrenheit, Celsius, and Kelvin. In Fahrenheit, water freezes at 32 and it boils at 212. Celsius, which makes the most sense, freezes at 0, boils at 100. I love Celsius. Kelvin, on the other hand, freezes at 273 and boils at 373. Now you will notice that there is a 100 difference in both Celsius and Kelvin. So Celsius and Kelvin are essentially just 273 apart from each other, but 1 degree change in Kelvin is equivalent to 1 degree change in Celsius. They equal each other. Now you might be wondering, why does Kelvin start at 273? Well, it doesn't actually. Kelvin goes all the way down to 0. Unlike Fahrenheit and Celsius, Kelvin can't be negative. And that's because 0 Kelvin is a theoretical state called absolute zero. Absolute zero is the theoretical point at which all movement, even atomic movement, stops. It has yet to actually be reached. Some theorize we can't reach it. However, it is a theoretical point. So 0 Celsius is water freezing. Perfectly normal, happens at all the time. 0 Kelvin is everything stops moving. So that's why it has a lot more room to move. You will notice, once again, that 1 Kelvin does equal 1 degree Celsius. All right. I know there's been a lot of information in this unit, but a lot of it should have been review, so I know you've got this.